The video. Today we're going to be looking at Leetcode 974, subarray sums divisible by k. We're told that we're given an integer array nums and an integer k, and we want to return the number of non-empty subarrays that have a sum divisible by k. And we're told that a subarray is a contiguous part of an array. So looking at the problem description, you may notice that it's very similar to another Leetcode problem that we've done, and that's Leetcode 560. So I would definitely recommend checking out the video that I've done for that Leetcode problem, because the intuition behind solving it is going to be exactly the same. That being said, although I won't go into the nuances of how to solve this problem using a prefix, sum and hash map, I will kind of walk through the intuition behind it if you have solved Leetcode 560, just so you know the differences between that implementation and this one. So let's I'm going to use this example. So let's say I'm just going to copy out the array that we're given, -2, -3, and 1. So that's the array that we're given. We need to find all the subarrays which have sums divisible by k. And we know something is divisible by k if, if we were to use a modulo operator on it, and divide it by k, and if that equal to 0, then boom, we found ourselves a number which is divisible by k. So let's actually walk through the problem. So 4, we come at 4. We encounter 4 in our list. It's the first element, and we say, well, let's plug that in. So let's say 4 divided by 5, or modulo 5, should I say. What remainder do we get? Well, we get a remainder 4, so we know that it's not divisible by 5. It's not divisible by k. So we put that into, just like we did with the Leetcode 560, we will have a prefix sum and we will have a count. So we will put our prefix sum 4 and we'll say we come across u once. And then we'll move on to 4 and 5. Well, is 9 divided by 5, or modulo 5, what is that? Well, that's also equal to 4, because 5 goes in once, but it gives us a remainder of 4. So, well, we know that 4 and 5 together don't equal to sum which is divisible by k. But if we look over here, we can see a 5 on its own is. So how would we isolate this 5 over here? Well, let's just ignore 4 for a second, and then we'll say 5 mod 5. What does that equal to? Well, it equals to 0. So we've found a subarray which is divisible by k. So how can we solve this problem? Well, we can rearrange this equation. We can say, if x minus prefix sum divided by modulo k equals 0, well, then we need to find p. We need to find our prefix, that if we subtract it from our sum, that new sum divided by k will be equal to 0. And the good thing is we're actually doing that already. We're storing all these prefixes in our hash map. So this is what our hash map is for. So all we have to do is say 9 minus 4, which is equal to 5. So we can say, in this case, 9, which is x, minus 4, which is a prefix sum, modulo 5 is equal to 0. And the 4 that we have in our hash map basically cancels out the 4 here. So that's the intuition behind solving this problem. It's practically the same. We're storing the prefix sum and the count, but the logic when it comes to actually doing multiplication and division, also doing division as opposed to doing addition and subtraction, is slightly different, but the core logic stays exactly the same. So let's actually get to coding. So kind of like how we did for Leetcode 560, we want to have a count, we're going to have a hash map. And initially we'll have 0 set to 1. And the reason for this I did mention in that video, but I'll go over it again. And that's if we have a number like 5 well, we have 5 modulo 5 equals 0, but we look in our hash map, and if we have not come across 0, then we're just going to increment our result count by 0, which is not what we want. So we want to set a placeholder as 1 to kind of handle this edge case. Then we have our result variable set to 0 and our prefix sum set to 0. And now we can say for each number in nums, let's increase our prefix sum by this number, and let's calculate the remainder. So the remainder is going to be equal to our prefix sum modulo k. And we want to say we want to increment our result by count.get remainder or 0. So if we've already found our remainder here, well, we can simply increment our result by that remainder. And that will mean the remainder will cancel out part of our subarray, and so we can get a sum which is divisible by k. And then we also want to set we want to increase the count of our remainder that we've already got. So we can say count.get remainder and 0. So now we increase our remainder in our hash map. And then we can simply return our result once we've finished our for loop. And we don't solve this correctly because Leetcode has not passed us. Let's look through the code. Remainder modulo k. This is the problem. So we're simply this won't set it to anything, it will just keep setting it to 0. We want to actually increment this by 1. So we want to increment our remainder in our hash map by 1. And we see that we pass all 67 test cases for this problem. So the time complexity for this problem is going to be the same as Leetcode 506. It's going to be a big O of n for both. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.